And of course, how do the spores of the fungus get from one tree to the other? They recruit a small marsupial, a little animal, potteroo or a bettong or something like that, or a bandicoot, that will move those fungal spores around. And that's a very, very simple example, but you've got to imagine an ecosystem that is built from thousands or millions of those elements working together to create productivity where inherently resources are so limited. And then imagine the moment that happened in this country 230 years ago, where a new species arrives with all of its domesticated animals, and that new species being us Europeans, not new species, but new form of life at least. And we set about changing the landscape. And through that process, in places like Victoria, the great majority of our middle-sized mammals that are so critical, play such a critical role in the ecosystem, become extinct. We change the nature of fire in the country, and that has a critical impact because fire in Australia fire here is our rhinoceros and our elephants. Some of you are from Africa and you're lucky to have those gigantic mammals that act as bankers in your ecosystem, that chew through that vegetation and then poop it out a day or two later with an interest paid on it, all of that benefit that you get in droppings and urine from big mammals. We don't have that in Australia. We haven't had it for 50,000 years. To recycle nutrients in the Australian ecosystem, you need to use fire in a very judicious way. Not fire so extreme that it burns the soil and destroys the soil sulphur reserves and so forth, but fire that's applied at the right moment, at the right time, in the right intensity to recycle the elements back into the soil and keep the biodiversity going. We lost knowledge of how to do that properly as Australia's Aboriginal people were dispossessed. And now we're trying to learn again how to get that key aspect of our ecosystem back into function. So in this country, we're faced with a number of enormous difficulties, I think, in terms of managing our biodiversity, because we live with a largely crippled ecosystem. So when we think about managing a park, it is very difficult to think of managing that park without considering the park's context, without considering the lands around it, the species that were once there, the fire regime that operated there. All of this here is critically important. Of course, such things are important everywhere in the world, but in Australia they are doubly important because of the inherent lack of resources that are available in this country. I might just spend a few moments for the benefit of our international visitors talking a little bit about our biodiversity here because it is intriguing and I think a lot of people don't understand it. You've come to a very strange country, all of you people from overseas, and it's very strange in part because it's full of things like kangaroos and koalas and other small native mammals, gum trees for example. And if you think about those creatures, I mean, they present some real enigmas, don't they? I mean, do any of you wonder why kangaroos hop? Has anyone ever considered that out there? It's not a question we often consider, I must say, but I spent a PhD, 3 years, trying to answer the question and had a lot of fun doing it. And why koalas have that sort of vacant look in their eyes, you know? Anyone wondered about that? And they're very slow. And why is it that this country is full of trees that have leaves that are shaped like a sickle, rather than what you see in Europe and North America of trees by and large that have leaves shaped like a hand? In Europe and North America, those trees do an astonishing thing. I lived through a fall in the US, and to see the trees throw their leaves away at the end of the year is astonishing. It's sort of like the McDonald's approach to, it's probably to life. Chuck them away once you've used them. An Australian tree would never ever do that because it fights so hard for the nutrients that it needs to grow that leaf and the basic elements it needs to grow that leaf. It hangs on to it come hell or high water. And that's where the koala gets in trouble because koalas only eat gum leaves, yeah? And the last thing a gum tree wants is for its leaves to be eaten by a koala. So it just fills the leaves with toxins. It can make the toxins pretty cheaply, it just needs a bit of sunlight and water. That's not such a problem, but if it loses the leaf, it loses all of the nutrients that are in that leaf. And so the koala has to spend at least 20% of its energy budget, which is already pretty miserly, just on detoxifying its food. So in evolutionary terms, has developed this enormous gut in order to do that. And that involves all sorts of trade-offs, because an animal can only do so many things at once, like trying to juggle more than 3 balls. It's really hard, you know. So the koala, through time, has sort of asked itself the question, I suppose, in an evolutionary sense, well, what should I do? Should I give away a bit of my gut, invest less in that? Should I invest less in my muscles? No, I need them to climb trees. What about the claws? No, I need them too. What about the brain? Well, there's a possibility. And brains, of course, are very, very hungry organs. You and I, sitting here this morning, our brain weighs about 2% of our body mass, but it uses 20% of the energy we take in. So 20% of your breakfast is going to feed this brain that only weighs 2% of you. If you're looking for energy savings, like a government looking for savings in different departments, you know, the brain is what gets targeted. So there's a good reason the koala's got that sort of vacant look, you know. There actually isn't much going on behind the scenes. It's the only mammal on Earth that's brain doesn't really fit its skull. So anyway, that's a... And I hasten to say, not all Australians have followed the same route, although occasionally driving on the road you might think otherwise, but we haven't. But it is a strange continent, and kangaroos are give another example of that. Why do they hop? The reason that they hop, and they're the only large mammal on Earth to hop, is that hopping is the single most efficient mechanism ever devised by a living thing to get from point A to B at medium speeds. It's far more efficient than running or walking or anything else. And on a continent where you've got long distances between water sources and food sources, you need to move about efficiently, particularly where resources as a whole are limited. Hopping, of course, you know, the reason that it's so efficient is that the animal can, as it hops and then lands, it stores all of the energy of the hop in its tendons and uses them to take off again, a bit like a pogo stick. It's an extremely efficient way of getting about the place. So there's a good reason for a lot of the anomalies we see in Australia. Those sickle-shaped leaves that protect the tree from losing too much moisture and that don't drop off in the autumn, through to the koala, through to the kangaroo, and through to, I just should mention one more, one of my favourite Australian mammals, a little animal called an antechinus. You might have noticed in this country that we don't have many big predators. We lack the lions and tigers and all that sort of stuff. Indeed, we lack anything like them that you see overseas. The biggest native predator still existing in Australia is a thing called the Tasmanian devil, and it's about as big as a bread box, about that big, sitting on this. And that's our hyena. Now, any of you who are from Africa or parts of the world where hyenas live know that they're a bit bigger than that, a bit bigger than corgis. But our ones are small, the native predators we do have. Again, just for the reason not much energy gets to the top of the food pyramid in Australia. There's a narrow resource base, yeah? So not a lot of it gets to the top of the food pyramid. And even our shrew-like carnivores have problems. One of the ones, the one I mentioned too, the antechinus, really tells us a lot about the nature of the problems they face. Antechinus are about a little bit bigger than a mouse, that big, obscure-looking brown animals that live on insects. And for most of the year, there's no adult males in the population. What happens is about August, September, the females give birth, suckle their young, and for about 10.5 months, the males do nothing but eat and grow. They remind me of teenage boys at a certain stage, you know. Just eat, 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 grow, grow, grow. But then, it must be around about July, August, the following year, something switches on in their brain. And all of a sudden, they forget about food, and all they can think about is sex, the males. So for 3 weeks, all they do is chase females around. And at the end of that period, they promptly drop dead. They've done their work. That's it. They've just given up on food. They just die. Again, there's some teenage boys, slightly older, who probably somewhat similar. But anyway. Now, why would that happen? Why in an environment would that happen? Why wouldn't a male seek to live to the next season, next reproductive season? The females can live several years, but the males all just live 11 months. The reason is, it seems, that in an environment where resources are so very limited, as is the case in our country, if the males were still in the population, the females, during a time that they're bringing up their young, would find it difficult to acquire enough resources to do that successfully. So it's better for that species, for the males, to drop dead at the end of the breeding season, and for the females then to have at least sufficient resources to carry on into the future. It's an evolutionary conundrum how such systems develop, but again they tell you a lot about life on this continent, that these little creatures just this big have such great difficulty requiring the resources they need to grow and live.